Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we have started the chapter SQL, Structured Query Language. In Structured Query Language, we are going to discuss joins in today's session. Let us start the session. What are joins or when we need joins? In general, joins are needed whenever we want to combine two or more tables. Whenever you want to combine two or more relations or tables. Two or more relations or tables. Let me give brief introduction about joins. Then we will discuss with examples. When we are discussing relational algebra, we have discussed what is a cross product. What is a cross product of two relations? Suppose I have R1 is first relation, R2 is second relation. Then the cross product is generally denoted by like this. For that, how to write SQL query? Select star. Star means all the attributes of R1 followed by R2. Select star from R1, comma R2. No need to specify any keyword for cross product, right? Suppose my relation R1 is having A, B. Relation R2 is having B, C. Then when we apply this query, the result will be all the attributes of the first table followed by all the attributes of the second table. What are the attributes of the first table, sir? A, B. What are the attributes of the second table, sir? B, C. Hope you understood it. So this is about the attributes. Okay. If you don't want to select all the attributes, then you can specify like this also. I want R1 attribute A, comma R2 attribute C from R1, comma R2. So in both of these queries, first it will form the cross product. From the cross product table, it will filter the columns whatever we need. That is about the cross product. Instead of that one, suppose I want to use join or natural join. When coming to SQL language, join or natural join, both will be used simultaneously. There is no difference, sir. Natural join or join. Depending on the software or depending on the DBMS we are using, there may be a small change in the keyword, but the intention is same. So either it is join or natural join. Then in such case, how to write the query? Select star from R1 join or natural join. In such case, what will happen, sir? It will display the records, that is the common attributes for only one time, and it don't display all the records, sir. We have already discussed what is the meaning of join in relational algebra. The same result we get when you apply this query in SQL. So this is brief introduction about joins. Before starting this session, I am assuming that you have attended join session in relational algebra, right? So let us continue. This is the example we are going to discuss for our session. Okay. Suppose student is the relation in which I have two attributes, student ID, name. Let us assume student ID is the primary key. Student ID is the primary key. Anyway, in our examples, we are not going to use the primary key concept. If possible or if needed, we use it. So let us assume SID is the primary key. Then coming to register, I think it is, yeah, register. Before going to register, this is my first table, sir. This is the course table. What are the course names and who is the faculty teaching the particular course? We are having DBMS, data structures, discrete mathematical structures, and the corresponding faculty names. Students will register the courses. When student register the courses, I want to form a new relation by taking the primary key of the first table, by taking the primary key of the second table. So for the second one, let us assume the course name is the primary key. So those we brought together to form a relation. This is the story, sir. Right? So this is the color. This is the set of all student details. This is the set of all courses. Right? This is which students registered which courses. Which student registered which course. So this is the example we are going to use for most of the questions in our session, right? So let us start it. Suppose we have written like this, sir. Select star from student S, register R. Sir, instead of writing this one, you can write simply select star from student, comma, register. But in the given one, what I done is, this is the alias name, sir. So S represents student, R represents register. Whenever I need to form some conditions, instead of using the entire word student, simply I can use S. Similarly, I can use R. That is the intention, sir. But the story is same. Here, if you observe it, we not used any keyword join. So it is equal to the cross product. It is equal to the cross product. How to form the cross product, sir? So the result will consist of the attributes student ID, name, student ID, course. Right? So these are the attributes we are having in the result. Now, what are the records? We already discussed how to form the cross product. Anyway, let me recall it again. Consider the first record. What is the first record? 22 Sudha. It need to be mapped with all the records of the second table. With all the records of the second table. What are the records of the second table, sir? 22 DBMS. 33 data structures. 22 discrete mathematical structures. So we considered the first record in the first relation and we are mapping that with each and every record of the second one. So we will write 22 Sudha 33 DS. Similarly, 22 Sudha 22 discrete max. So we completed the first record. Let us consider the second record Sita. The same process we need to do, sir. So for Sita, again map with 3 records. What are the 3 records, sir? 22, 33, 22. So the first one is 22 DBMS, 33 DS, 22 DMS. So this is for Sita. Then we completed the second record. Go to the third one. Geeta. 33 Geeta. Again the same story, sir. 22 DBMS. 33 DS. 22 DMS. This is about the cross product, right? We not filtered any records, any attributes, right? Whenever you want to filter the attributes, what you can do, sir? You can specify s dot name. Then it will display the attribute name from the first table. Suppose I want the course also. So r dot course. Then it will give only two attributes, name comma course. Then how to filter the records? Okay, for that either you can specify clearly, okay, on our own, or you can go for joins. For example, the same SQL query I am going to write like this: select star from student S. You can give any variables, are not only S. Okay, for convenience we have given S comma R. Select star from this, but I don't want all the records. What I want, where s dot sid equal to r dot sid, because whenever the student id in the first table is equal to student id in the second table, then we may get some relevant information, right? Because please observe this set. This set 11 Sita, 22 DBMS. Why Sita need the details of 22, sir? Why Sita need the details of 33? Right? If there is some details about 11 Sita, then we may write it. So that's why I taken s dot sid equal to r dot sid. So s dot sid is equal to r dot sid. So this will be there. S dot sid equal to r dot sid. It is not. So it will be striked out. Then s dot sid equal to id. So this will be done. 11 not equal to 22. Strike it. 11 not equal to 33. 11 not equal to 22. Then 33, 22 not equal, sir. Leave it. 33, 33 S. 33, 22. Leave it. Instead of equality, you can specify greater than, less than, any condition. And condition is not only the same attribute, sir. Okay. You can have anything. S dot sid equal to r dot some PID. Of course, we don't have any PID in this, sir. My intention is we can write the condition on any set of attributes. That is the intention. Hope you understood it. Fine. I think the same example we have seen, sir. Select star from student S, register R, where S dot SID equal to R dot SID. So this is the story, sir. Right? Instead of equality, because we have already discussed equality. Am I right? So we already discussed equality. Let us suppose I have less than. Let us suppose I have less than. Then what are the records you can have, sir? This is the result of the cross product. Even internally also, first it will form the cross product, then only it will filter the records, right? So this ID must be less than this ID. It is not true. 22 less than 33, fine. 22 less than 22, not true. 11 less than 22, fine. 11 less than 33, 11 less than 22. 33 less than 22. No. 33 less than 33. No. 33 less than 22. No. Hope you understood it. So instead of equality, less than, greater than, not equality, even two conditions, three conditions, you can have any conditions. Hope you understood it, right? So in the same query, I can write s dot name equal to Sita also. So you can add any number of conditions. Since you are dealing with two tables or two relations, you need to specify like this, like our structures and members in C language. S dot name, name attribute of the relation S. Hope you understood it. So let's go to the next one. Now look at this, sir. The same story. Select S dot name. Now I am not selecting all the attributes. In the previous example, we selected all the attributes. So all the attributes will be displayed. All the four. Now it is not like that. I want only one attribute. But the condition is same. So this is the table, sir. First, it will filter the records. Equality. This is fine. This is not fine. Fine. Not fine. Not fine. Not. So totally how many records you are having, sir? Let me write it clearly. SID, name, SID, course. So the first record what we have is 22 Sudha, 22 DBMS. So Sudhakar or Sudha, the student roll number 22, he registered the course DBMS. That is the intention of the first record. 22 Sudha, 22 DMS. So he also registered DMS. Then 33 Geeta, 33 Geeta. She registered data structures. So this is when you apply the where class. Now from this, I don't want all the attributes, sir. I want only the names, because you asked only the names. So in the result, what you get, sir? Names only. S dot name. What are the names? Sudha. The question is whether Sudha displayed for 2 times or 1 times. Can anyone answer, sir? Sudha displayed for 1 time or 2 times? Anyone, can you answer it? SQL don't eliminate duplicates on its own. If you want to eliminate, you need to use the keyword distinct. If you don't use distinct, it will not eliminate any duplicates. Right? So Sudha will be displayed for 2 times. Geeta. Hope you understood it. So this is the result of the given query. Is that clear? Let's go to the next one. Now look at this, sir. The same example. Now I am having 2 conditions. This is my first condition. This is my second condition. Both SIDs must be equal and course must be equal to DS. Course must be equal to DS. Right? So this is the story, sir. Whenever they are equal, we will get this one, first one, third one, and these are the stories. Now from these, how many you need, sir? For our clarity, let me write it again. SID, name, SID, codes. From the first condition, what are the records you got, sir? DBMS. Then the next one is 22 Sudha, 22 DMS. Then the next one is 33 Geeta, 33 DS. Now what is the second condition, sir? The second condition is codes equal to DS, that is data structures. How many records you are having, sir? You are having only one DS. So the first will be discarded, the second will be discarded, only this one. Now in this record, do you need all the details? No, sir. I need only the name. So I will get S name, in which I have only one record, and that record name is Geeta. Hope you understood it. Then let us go to join, natural join. Sir, in natural join, simply the condition is join equal to cross product plus extra condition. So it will form the cross product only, but it don't display all the records. It will have one extra condition to filter the records. What are the extra conditions? Suppose I have one common attribute X. Assume S is having X, R is having X. Then the extra condition is S dot X is equal to R dot X. Suppose I have two common attributes SY, RY. Then it should be S dot Y equal to R dot Y. Like that equality condition for all the common attributes, not for some, sir. So compulsorily equality condition on all common attributes. And since we have given equality condition, the common attributes will be displayed only for one time. Because both are having same values, right? When both are having same values, why to write for two times, sir? So let me rough this, sir. Right? So the same. Here I have only one common column. So this will be written, this will be written, and this will be written. And one more is the common column will be displayed only for one time, because we are not writing any general condition like greater than, less than or equal to. We are writing only equality. When equality, both columns will have same values. When same values, no need to write for two times, right? So that's why we are writing one time. Now look at this. This will be more meaningful. 22 is the rule number. Sudha is the student name. And DBMS is the course he registered. Now this record is having more meaning than comparatively the previous records in the previous examples. Similarly, 22 Sudha. he registered discrete mathematics also. Right? And we have one more also, 33 Geeta. What she registered? She registered DS. Hope you understood. Now join will give the more meaningful way, because I have student personal details in one relation, student registration details in second relation. I want to combine these two to get more useful information. That is the main use of join. Whenever I have information which is spread among two or more tables, then we use this concept join. Right? So suppose they ask like this, list the names of all students who registered at least one course. Who registered at least one course. Right? Suppose I have a student X. If he registered one course, what will happen, sir? X will be in register table. One minute, sir. So suppose this is my student. Whenever he registered at least one course, surely his name will be in register table. Suppose that particular student not registered any course, his name will not be in register table. Even X registered for 2 or 3 courses, his number will be appear for 2 or 3 times. Right? Here please observe it. 22 registered 2 courses. So his number is in the table. 11 Sita, she not registered any course. Her number is not in the register table. 33 she registered. So her number is here. So whenever a student registered a course, his number will be in register table. So what I can do, sir? I can form the cross product and I can verify whether SIDs are equal or not. If SIDs are equal, what does it mean? This fellow is present in register table. So he registered one course, right? So it is like this, sir. Select star from student S. No need to write alias names always, sir, but it will be a good practice. Register R. Do you need to specify any conditions, sir? No. Join itself specifies. Join itself specifies S dot SID equal to R dot SID. And you are not concerned about any particular subject, right? So this is enough. Now the question is, do you need all the details, sir? No, I need only the names of students, right? Name is present in which table? Student. So instead of writing star, here we write S dot name, right? And one more is, if name appeared for only one time in these two tables, okay, you can eliminate this S. Simply you can write name. But it is a good practice to write S dot name, because there is no problem even if you write it. It will give more clarity from which relation you are collecting the attribute. Hope you understood it. Now look at this. List the names of students who registered the course DBMS. Now I don't want all the things. Student will be in register table. Sure, but that registration number must corresponds to DBMS. If it corresponds to something else, I don't need him. right? So what I can do is select star from student S, join register R. Join itself specifies SIDs are same that we already written, sir, where we have one more condition. What is that condition, sir? The course name from registration table, that is the course name from registration table, must be equal to, what is that, sir? DBMS. Hope you understood it. Next, look at this. List the names of all students who registered the course taught by PVR. Sir, student, it is in the first table. If he registered, he will be in second table. And the corresponding course name, what is the course name, sir? ABC. It's not ABC, sir. I want to know the course taught by PVR. Where is PVR? In third one. So I need to combine the first table, second table, third table. That's the first story. In third table, the name, the instructor name, faculty equal to PVR. Then it will give the details of courses by PVR and the corresponding records. Now the second condition is what, sir? These two already we form as a join, sir. No issue, right? So we got the faculty name and the second table course and the third table course, that is second table course equal to the third table course. In third table, as of now, we have only PVR courses, that is DS, DMS. So whenever the second table courses contains DS, DMS, all those will be displayed. So how to write it, sir? Look at this. Select star. Okay, instead of star, you can write names or whatever you want. Now you need the information for three tables. Student S. If you want, you can apply joins, or if you want, you can specify the conditions explicitly. Okay, that depends on your choice. In the previous two examples, we used join. So that's why for this example, let us write explicitly. So register or course C. Sir, with this, it will form the cross product of S dot R dot C. But I don't need all the records. First, filter the records in which course faculty equal to PVR, where course faculty equal to PVR. Then I will get only the subject PVR, that is DS and DMS, and this subject must be equal to in registration and C dot course name. Now we got the course name by PVR. This course must be equal to in registration and that course must be registered by our student. So R dot SID equal to S dot SID. Please check it. If you have any doubts, please raise in chat box. Let us go to the next one. Right. So let us solve one previous question, sir. Just go through the question. Consider the set of relations shown below and SQL query that follows. Fine. We have three tables: students, courses, grades. I think almost similar example what we discussed. Instead of register, we have grades. That's it. In students, I have rule number, name, date of birth. Fine. Rule number, name, date of birth. That is the first table. What about the courses, sir? Course number. Okay, they may have given something like course code, course name, and the faculty, instructor or faculty, anyone. What about the third one? Rule number, the student rule number. What is the course number he registered? In that course, how much grade he got? Something like a student rule number 22 registered some C101. He got some A grade. The same student 22 may register in one more course C104. He got B. Or I may have student 33 who registered C104 and let us assume she got C grade. Like that, this is the story. Right? Now what is the query, sir? What is the query? Select distinct names. So I want names and the name also only for one time. Duplicates are not allowed. Up to here it's clear, sir. Distinct names of students. Sir, please observe it. They given simply name because in all the three relations, name appeared for only one time. When it appeared for only one time, no need to specify the corresponding relation name. That's what I told. If name appeared in two or three relations, then I need to specify which name you want. That is the name from which relation. Now it is students only. So distinct student names. Fine. From students, courses, grades and everything, sir. Now look at this. Student dot rule number equal to grades dot rule number. So this rule number should register some course and course instructor equal to course. Course is the faculty name and the course instructor. Whatever the student registered the course, it should be instructed by this course. And one more condition, sir. Course number equal to grades number, because with this you filter the courses by course and those courses must be same. And look at this. Grades dot grade equal to A. So what does that mean, sir? Let me explain in next slide. Now look at this, sir. First, the first condition. Courses dot instructor equal to course. So with this, you are concerned or you are confined only the courses by course. Only the courses by course. The next one. Sir, this rule number condition, this course number condition, both are only to join the records only. Now look at this. Grade equal to A. The second condition. Grades dot grade. That means, suppose course taught DBMS, DS. Then student must register any one of these two courses and his grade must be equal to A. Am I clear, sir? Because grades dot grade equal to A. Suppose Suppose we are having like this, sir. Some student 22 registered DBMS. In DBMS, he got A. The same student 22, he registered DS, but he got B. And let us assume the name is Sudha. Then what will happen, sir? When you filter, this record will be deleted, but this will be there. What does that mean? Whenever a student registered so many courses by course, to have that name in my result, he need to get at least one A grade. Suppose Sita is there. Sita is there. She registered both courses. She registered both courses. But in both courses, she got B grade, C grade. Then since grade is not equal to A, I strike out Sita, I strike out Sita. So Sita will not be in my result. Right? So that means whenever a student is in my result, what does it mean? He got at least one A grade. Maybe more than one. Whenever it is more than one, the student name will be appeared for 2 or 3 times. But I display only for one time because we are using distinct. But if he got less than A grade in all the subjects, then his name will not be displayed. So what does that mean, sir? Students who got A grade in at least, not all, sir, no need of all. Maybe one record will be eliminated like DS, but the first record will be there. At least one subject taught by course. Right? So what is the answer, sir? Let us check it. Names of the students who got A grade in all courses by course. It's not, sir. It's not all courses. Here in all courses, they not specified faculty name. It's not. A grade in at least one course taught by course. So C is the correct answer. Please check it, sir. So we have one more, sir. Database table by name loan records is given below. So this table name is loan records. Fine. Now look at this. Select count of star from. Now first of all I need this table. What is this, sir? Select borrower branch manager from loan records. So it is taking two attributes from loan records as yes. It is taking branch manager loan amount from loan records as T. Again it is taking two records. Then it is applying natural join. After applying natural join, it is counting. Right? So let us do it. The first step, sir. What is yes? In yes, what you are selecting? Borrower bank manager. Borrower bank manager. Right? So what you are having here, sir? Borrower is Ramesh. Bank manager Sundarajan. Okay, let me write Sundar simply. The next one is Suresh Ram Gopal. The third one is Mahesh. Again, I think he is Sundarajan. So Sundar. So this is yes. Am I right, sir? What is T, sir? For T, I need bank manager. Loan amount. So the first one is Sundar. I think it is 10,000, right? Then Rangopal. 5,000. Then Sundar. 7,000. Up to here clear, sir. We got two records separately. For these two, we need to apply natural join. Natural join. When you apply natural join, the common column will be displayed only for one time. Borrower, bank manager. Don't write bank manager for second time. If you want clarity, you can write it, sir. Then loan amount. Consider the first one, Ramesh Sundar. If there is a match, yes, match. For second one, no match. For third one, there is a match. So this will be Ramesh Sundar. For first time, it is 10,000, sir. For the same Sundar, it will have a match with third record. It is 7,000. So that is about the first record. Then what about Suresh Ram Gopal, sir? Suresh Ram Gopal, it is having only one matching. So it will be written only for one time. Let me write Suresh Ram Gopal and the loan amount is 5,000. Fine. Then what about the third one, sir? Mahesh, again Sundar. Sundar is having two matchings. Mahesh, Sundar, 10,000. Mahesh, Sundar, 7,000. That's it. This is the natural join. So we got the result ready, but they don't want the result, sir. Look at this. Select count of star. That is the number of records. What is the number of records in this table, sir? The number of records equal to 5. So the answer is 5. Hope you understood it. The next one, given relations R with two attributes. So we have a table R in which we have two attributes W, X. S, we have Y, Z. Now look at this. Select W comma X from R comma S. That means they are forming Cartesian product only. They are forming Cartesian product only. Okay. But they are selecting, sorry, sir. Select distinct W comma X from R comma S. Sir, this meaning is cross product. R cross S, right? Then is guaranteed to be as same because they are selecting only the attributes of R only. They are selecting only the attributes of R only. Okay, but will you give guarantee always? Maybe or may not be. Then what are the conditions? R has no duplicates. S is non-empty. Okay, let me write, I think, next slide. Fine. So let us write it here. R is W X. What is S or Y Z? I think better to have options in one slide. Just 1 second, sir. Let's go. Let's do it here only. Because we need to work out with respect to these options. Okay, let us continue. R W X. The next one S Y Z. Suppose this WX I have 1 comma 2, some 3 comma 4. Here I have some 5 comma 6, 7 comma 8. When you form R cross S, what will happen, sir? W X Y Z. 1 2 will be displayed for 2 times with 5 6, with 7 8. 3 4 will be displayed with 5 6. 3 4 will be displayed for 7 8. Now from this table, if you directly write this one, select W comma X. If you write directly W comma X, surely it is not equal to R, sir, because 1 comma 2 1 comma 2 displayed for 2 times, right? But they given distinct. Fine, so no issue. Now look at this, sir. Suppose R has duplicates like 1 2, one more. Then for this also I write 1 2 5 6, 1 2 7 8. When you apply distinct, that is select distinct W X, then what will happen, sir? I will get only 1 2 3 4. But the original is having 3 records, but it is having only 2 records. So compulsorily R should not have any duplicates. So R should not have duplicates. It's fine, sir. Okay. Then S must be non-empty. Yes, of course. Suppose S don't have any records. Let us assume S is an empty table. S is an empty table. Then with whom you match, sir? You cannot match anything. R cross S is empty set. So no tuples. When no tuples, again, how can you recall these records, sir? It's not possible. So compulsorily, the first one is R has no duplicates. The second one is S is not empty. Because if S is empty, the cross product will become empty. Because when S equal to empty, then cross product will be empty, sir. So R has no duplicates and S is empty. And please observe it. Here they not given any non-empty condition here. So it will not be, sir. S has no duplicates. Since you are concerning about the first relation, no need of about the second one, right? So the answer is Option A. Hope you got it. So that is about joins. In next session, we will discuss nested queries. Thank you.